All right, last example for today. Example 5, we are now going to be doing the opposite. What if we are given the parabola and we have to write the function in factored form? All right, step 1, we have to find our x-intercepts. Looking at our graph, we can see exactly what those are. X equals 1, x equals -5. Since we know what our x-intercepts are, we essentially know what the solutions are, we're actually going to use that and work backwards now. And we want to plug these back into factored form. So let me actually use a different color here. We want to plug these back into factored form. So what factors result in me getting those answers? Well, we kind of have to flip our signs around. And because that, remember, that's because when we take our factors, we set them equal to 0, and we solve to get these answers. So these factors, x plus 5, will result in getting our x-intercept of -5. X minus 1 will result in us getting a x-intercept of +1. So that right there is our step 2. Write them in factored form. And what our goal is going to be in just a second here is to find a. Because we do already know our x-intercept, we know our y-intercepts, we even see our vertex. But if we want to write the function in quadratic, write the quadratic in factored form, we're essentially looking for our slope, looking for the a value. So if we're going to solve for a, I can't have x and y be missing unknown values as well. So this is where we have to go back to our graph and find another coordinate point. Now, there's a lot of them. You can pick any point on this parabola. You could pick the y-intercept. You could pick the vertex. You could pick any other random point. All of those points are just x, y values, and we need to plug something in for x and something in for y. So that third point, you can pick any point on the parabola. I like to typically go for either the y-intercept or the vertex, just because they're typically easier numbers, but you can pick any point on the graph. I'm going to go with our vertex. I'm going to use that coordinate point. So it looks like that point is sitting at -2, -9. And that right there is what I want to plug in for x and y into our factored form. So I'm going to go ahead and rewrite that now. -9, we're plugging in for y. A is the only thing that we should have missing. X minus 1 was our first factor, x plus 5, except I want to now get rid of those two x's and plug in our x coordinate that we chose, -2, -2. All right, notice how we finally just have one value missing. That's exactly what we want. If we have more than one unknown, we're not going to be able to solve for anything. That's why we have to plug in our third point. Now we're just going to use some algebra to solve for a. All right, I'm going to start with simplifying these parentheses here. We're going to get -3 for the first set of parentheses and +3 for the second set. Bring down a, bring down -9. All right, I'm going to bring this up over here a little bit. I'm going to multiply our two numbers here. When we do that, now we have -9 equals another -9 when we multiply -3 and +3. And then the a, I'm going to squish up against that now. And we have one more step to solve for a. We're going to divide by -9. And when we do that, we are left with 1 as our a value. All right, so now that we found our a value, we can go back to our original factored form. Y and x can go back to being their unknowns as before. But now we know what our a value is, and we know what our x-intercepts are. So we're going to plug in 1 for a, and plug back in our factors exactly how they started. This right here, we could simplify more. We could put it into standard form, but regardless, however we write it, that is the shape of our graph.